Hello and welcome to our webinar, Model-Based Systems Engineering Driving More Trade-Space Analysis. My name is Michael Gans, Senior Program Manager for Life Sciences at Dassault Systèmes, and I will be moderating this session. This is the fifth and final webinar in our series, Model-Based Systems Engineering for Life Sciences Applications, in which we are covering numerous topics we hope will help you advance your MBSE practices. Now it's my pleasure to introduce today's speaker, Saulis Pavalkis. Saulis leads MBSE transformation towards using standards such as SysML, UML, FUML, and integrated engineering and business ecosystems in the 3D Experience platform. Saulis delivers MBSE solution working with the Dassault Systèmes pre-sales team. Saulis is a community author for simulation and MBSE success cases, as well as an author for multiple samples, solutions, and papers. Saulis also represented Dassault Systèmes at multiple INCOS and NDIA events, delivering MBSE and SysML simulation training, and SE transformation consulting, coaching, and project support. And now, without further ado, I'd like to turn the webinar over to Saulis to begin his presentation. Saulis, it's all yours.
Thank you very much for introduction and for opportunity to speak today. So we'll cover following topics: introduction to MBSE with SysML and Catia Magic, cyber systems engineer, or old name Cameo systems modeler, systems architecture simulation analysis in SysML, plus demonstration, very short one, MBSE ecosystem, multidisciplinary simulation orchestration analysis with Process Composer, connecting Cameo models to 3D Experience platform models with Process Composer plus demonstration again. Then client use case, it's a new thing, so there are not so many client use cases in specific disintegration, but in industry there are a lot of cases of the opportunities to get those integrations working and delivering value. And then next steps, what will happen in the closest future, and the conclusions. So now introduction to the MBSE with SysML and Magic cyber systems engineer from Catia Systems. Again, the name was Cameo Systems Modeler, which product you can still find both names with. Pretty much, Magic is the leader, and the product suite under the Dassault Systems is the leader in the MBSE solutions for system modeling mostly, but then also system simulation, because the models can be executed. They are formal enough, to be executed and completely, almost all the diagrams, like behavior diagrams, parametric diagrams, as you can see, also including, user interface prototyping and analysis on top of that. This is different analysis because some executable model is descriptive model of the system, and we just put on top of that additional things to make analysis work, and that's why we so looking forward for any other abilities to integrate with analytical models which are already available, in the huge opportunities in the 3D Experience platform and the design models. So what is the MBSE in short? So it is really integrated models, or providing single source of truth, and currently in the recent years, maybe 10 last years, with accelerating faster and faster, the industry of system engineering is migrating from document-based approach to model-based approach. So model-based approach for system engineers is the actual system model which describes the system as requirements for the system, including text-based requirements, but also model-based requirements, and providing it as a source for all the stakeholders, not only system engineers. So system engineers are contributors, but even other roles are contributors to the model. Safety, for example, is done on top of the model, not isolated, and then outputs are generated. So this is different from the document-based approach, where you build the artifact from scratch, even in Excel, even in Word, which is like a kind of, digital thing, but still you build it from scratch. You don't kind of put data on top of the model to generate the report, but you build the report which increasing consistencies and so on. With the MBSE, we eliminate that as much as is possible. So this is that transformation which is going on. Aerospace and defense is very fast in that. Other industries follow, like TNM and healthcare and medical devices, especially in the healthcare. So where is the value from model-based system engineering and from system engineering in general? So this is investment in the definition phase in order to eliminate the issues on the later phases, like this detailed design phase. So if we want to get good quality, so we invest, and there are studies done, that 13% of the budget should be invested on system engineering upfront. It's like a front investment. Then we produce better requirements. It's not waterfall. It's not that we produce requirements and someone will consume them, as a kind of holy grail of requirements, but it is iterative process. Plus we take some components from the already designed, so we integrate, but we solve the problems, by defining in the model and up front in order to provide correct requirements for many other disciplines like software, electrical, and mechanical. And you can imagine if there are mistakes, in software requirements and electrical and so on, that will cost a lot. And it is okay to integrate and find those problems, but that will cost much more than at the beginning to develop, correct, kind of settle down on the common agreement, what system will look like and what are the demands on the system based on the stakeholder needs. So that's what happens in aerospace. That's what happens in automotive. Aerospace always had a system engineering and defense, very widely used for the innovative projects because, again, of the innovation. And TNM, transportation and mobility, especially currently, with all the software and the systems and electrical and artificial intelligence and whatnot, in the systems, they see the innovative projects, so they need system engineering, which is kind of created to address those problems. And same other industries like mechanical, like medical devices with innovative projects, we need highly system engineering involvement. So what we get, as a result is the integrated ability to have integrated models. So here we see this traditional system engineering view. It's not representing really a waterfall as just one step and delivering to another step, like from requirements to system architecture to subsystem design to component design and then integration, development and integration and testing. It is actually iterative process, but because we kind of now use the models for systems, so we can integrate those models with the design models and use them for the analysis and model-based testing for verification, virtual verification. And even better, if those models are executable, then we can do analysis directly. We can run the system, a digital copy of the system, even at system level with integrated design and analysis models. And we'll see how that works today. So system architecture, simulation, analysis in SysML. So there are a few steps in the maturity of the models, and you will find those steps in most organizations and in most projects. So first of all, this is not the only this is not the only maturity levels. There are many more, based on INCOSE recently developed MBSE maturity level evaluation methodology, I would say, but this one is very popular, and it is just recently provided by experts from the aerospace, so it is a very good one also. So here we see that at the beginning we have independent models, which are really not producing, a single source of truth. You have those models, everyone has those models. In this disconnected models around the company for specific type of analysis, right? Then we have system modeling, which connects the model, which describes the system in the model as what you expect or what it is. Then we can execute the system if we are running the if we are using the formal languages which can be executed, like SysML, like Modelica, preferably SysML, which is like de facto standard for systems modeling, you can execute it, and then you can do, validation at least of your logic, demonstration of how the system will work, check that you kind of created what you expected, even used correctly SysML, but then also do some analysis on top, and then integrate those models. And you integrate your analytical models with system models, you get inputs from system model, you can do the trade studies and other things. And then last is the optimization. So this is the highest maturity level we talk about in this webinar. This is when you have closely integrated your analytical models with system model, and then you can run what-if scenarios, trade studies with the detailed design models and analytical models, which already exist in your organization. Also, there are many tools which provided by 3D Experience, and then we can connect them to system model, and then we have full loop from stakeholder needs to the detailed analysis and design through the simulation, and we can achieve the optimization. So this is worth reaching, because this is the highest maturity, and this is not happens immediately, step by step, but at the end, we'll get the most from the MBSE adoption. Now, what are use cases? System level trade studies, for example. We have alternative architectures. Here you see in the corner, multiple solutions possible, sometimes million solutions, sometimes just like few solutions, which we say, okay, we can pick this component and this component, like a bigger battery, smaller motor, and so on, so on. Many configurations possible. And then we can do the trade studies, and we can do just in the system level, but also we can actually replace parts of those components with the detailed design models and run through the analytical models, which are in our tools. So we can achieve that through integration with the models. Parametric optimization, parameters optimization, right? Another use case. And here we see like some screenshots from the presentations from the Lockheed Martin, where it's described, like behavior and performance constraints and analysis, like because we have like behavior models, so they have workflows as activities, states, and they can be optimized, requirements constraints checking, requirements validation verification. So we think that system will work as expected, but with connection of the detailed design models and analytical models, we might see different results, and we could get that immediately if we have connection. Now, this all stands on top of the ability to execute the system model, and behind the scene is executable system model in SysML, which is evaluated by the multiple evaluation engines. Like here you see like activities, composite structure, state machine, scripts, parametric sequence diagram evaluation. Those are separate engines working behind the scene based on the standards, but also we work together, to evaluate just the model, so user don't need to think that there are some other standards behind. It's all standard based. You just run the model and you get results. And there is animation, debugging, ability to do many analysis like requirements verification, trade studies, timing and duration analysis, Monte Carlo analysis, model-based testing, co-simulation. But this is very limited, to what integrations you will have, if you want to integrate your other tools, for co-simulation. And what we'll show today, it removes that limit. It pretty much enables, integration many other tools, and huge 3D experience ecosystem capabilities, pretty much. So what is the MBSE ecosystem? So this is really well explained in this very old, actually, slide. Part of this slide is very old. Just recently, actually, it was reused. Just like this week, we have modeling and simulation conference, 3D Dassault system modeling and simulation conference, and the slide was reused again. A few years ago it was created by Navier, and this explaining digital strategy. Huge documents were created, how the Navier will need to transform itself. And part of that was this piece. So as you can see here, it is coming from Sandy Friedenthal book, Practical Guide to SysML, where we see that a system model is not in isolation. It talks with the requirements. It gets requirements created, and as input, it integrates with analytical models, and it integrates with the design models, detailed design models, back and forward, right? We can't say that we produce just requirement for design. We need to get also parameters from design to take the correct decisions, to do the multidisciplinary trade studies at the system architecture level. Otherwise, it will do uninformed decisions as a system engineers. Some components will already be designed, so we need to take parameters of those components when we do trade studies and evaluate alternatives and so on. So, just to say that this again, 10 years old and even more older, this is SysML part, maybe 15 years old by Rick Steiner. So all of that, is like last, 15 years, a lot of industry adoption, a lot of academia and practitioners, consultants, working with multiple methods adopting, but tool vendors are the key here, providing the connectivity and removing the user needs to develop some integrations, which we are kind of talking here about the tool vendor power here in this connectivity. And from the source systems, we see here, we have requirements, we have analytical models, the MOLA, Simulia, huge analytical model potential and a lot of different analysis. We have design, right? 3D CAD, electrical, fluidic, electronics, all of that, right? Software, all those pieces, and system model is actually, it's not that it's tying all them together, but if you develop new system, right, we need to know about them and leverage them, and they need to know about what we want from the system. And system model digitalize that, right? So it provides that as an input to the analytical models, what we select as architecture, we provide that as requirements for the design models, and get also feedback, what would be the existing components in design, because we already have 90% of them. We just need to innovate and create some changes. So now we'll talk about multidisciplinary simulation orchestration analysis with 3D experience process composer. The multiple roles in the 3D experience platform, and some of them I will talk about here. So you can see here products like Simulation Companion, Process Composer, Process Studio, Performance Study, and Results Analytics. So a lot of ways to analyze results, but mostly we concentrate here in the Process Composer in this demonstration in this webinar, because this is the place where we kind of integrate, system model, and we get the other models in the loop, with help of Process Composer. As you can see here, we have ability to create the workflow with the Process Composer. The Process Composer captures this, graphically. It's easy to capture the workflow. We can use the connection connectors, just drop those connectors on the workflow and we'll get them, we'll provide the parameters and connectors, and those connectors will connect to our products, internal and external products, for 3D experience. This is amazing. So this is very simple to use, and this works, across different industries and across different simulations. We can exchange data from one tool to another tool, and we can also, run multiple analysis, capture results of analysis. What we have here is activities and adapters. You see here activities. Those activities can interchange parameters, with the data sources, with other activities, and those adapters, like for example, this one, calculates, so it's like some math, right? This one connects to some software, can run the software, and read the file output from that software, like Catia, for example, Cameo Systems Modeler, this one. And tons of connectors, right? You can even create your own connector. So there are a huge amount of connectors, and there are some connectors which connect, native tools. I mean, like native tools. That's the easiest way to work with. 3D CAD. Some simulations, on the CAD and other types of simulations. And then outside connectors, also you can connect to the other tools available in your organization. What it gives, it automates automated exploratory hierarchical processes, and you run those models connected together for the co-simulation, or just for the orchestration of simulation, and you get results, the optimization, trade studies, parameters, right, from the up to the stakeholder needs from the top. There are support for multiple design exploration techniques, as we can see here. Monte Carlo analysis, approximation, sensitivity analysis, optimization. Now, how this integration works? Cameo model to submit simulations for process on the platform. So this will talk about this. So there are two really current use cases, which from the technical side, which we are able to exercise. The first one is the ability to call the process simulation experience directly from the SysML model. So you execute the SysML model, and an activity, really an opaque behavior, which can be executed in multiple places, not only an activity, but an activity, let's say in the middle of the workflow, you can call the simulation experience process, from the 3D experience platform, provide parameters and get results. So whatever you have already, you can reuse it. You can reuse it easily from system perspective, and then can evaluate the results of the simulation in the SysML. Another method, actually, which I will not talk so much today, but which also is available actually even now, you can, because a process composer can have the connector to run the external tools, and Cameo can run in the headless mode. So you can use the connection to the Cameo and through command line, run the Cameo and get the file output of simulation and read that file data. So you can run from process composer Cameo. So that would be like this connector running the Cameo and then reading results after, and then doing something with the results. Then you don't see that simulation running in SysML. It runs in headless mode. It starts the tool automatically when the time comes, and then closes the tool. This one is actually execute system model. You execute it, and then you run it at the right moment. It goes to the 3D experience platform, takes the runs the simulation, takes the data back as a result of simulation, and comes back and passes the data as a parameters. So those are two methods. Now I will talk about this A method, running simulation from system model. So first of all, you install a dedicated plugin into the Cameo. This plugin, I will talk about the release date. It's not yet available. It is in pre-production, in production phase, which just in selected clients, demo case available and proof of concept case available for selected clients. In any case, so the process is like that. You install the plugin, maybe natively will be available based on the licensing, this plugin on the Cameo. Then you connect to 3D experience platform. Then you get the list of the simulation templates. Those are regular simulation templates from 3D experience platform. They are parameterized. So you drag and drop the selected template to the activity diagram, and you get the action with the parameters. So then you run simulation. If you run simulation, you need to connect to the 3D experience platform. If you are not connected, then that's just run it. And then the process is created and it executed on the 3D experience platform, and that will produce the results, and the results you will receive in the SysML model as output pins. that's the process how that will work. And then we can run that a few times. So there will be demonstration. Here we see this demonstration recorded. It's not the final view how it will look like, but here we see that we have calculator with some parameters, and we package it as a process. And then we go to the Cameo. We will see that we have those, so we are creating simulation templates, and those simulation templates will be visible from the Cameo. So then we'll go to the Cameo in a moment, and we'll select the simulation template, and we'll just drag directly to the diagram. We'll see that. And based on those parameters are in and out or in out, we will get pins in activity. So the pins also can be in, out, and in, out. And parameters actually activity can be in, out. That creates like in and out pin, if it is in, out. So we take it, and we drop it. Here we see there is intermediate step when we drop in opaque behavior, but really now in the release will be just dropping on activity. We'll get this kind of activity which will run automatically this template. So we don't need to care, about integration details. We just connect and that's it, And then as a result, we'll get the, result back to the model, and we just get executed the template-based process on the 3D experience platform from SysML model. So now I will demonstrate one of the use cases which are available as a result of the presentation done last year in the Modeling and Simulation Conference, the Dassault Systems Conference. It is Lockheed Martin use case, and they presented EXPEDITE initiative. There is aircraft conceptual design using 3D experience simulation process and design exploration apps presentation done. And this, what is EXPEDITE? It is Air Force Research Laboratory, expanded multidisciplinary optimization, MDO, for effectiveness-based design technologies. EXPEDITE program intends a rapid improvement in the aerospace industry, early conceptual MDO capabilities, model disciplinary optimization capabilities in several key areas. Effectiveness-based design, state-based modeling and path dependency, transient operation of systems and subsystems, and transient quantification. So you see here is all the values, which you can get from 3D experience, plus the system engineering in the loop because of the connectors which we are talking now, And they evaluated this capability, as you can see here presented. There is the DS, and that presentation moment, last year, it was mostly physical models connected, but now they also connect the Cameo systems model in the loop, which provides the architectural data input, and then we get parameterized optimization on the aircraft geometry, on the some other characteristics which we can't, talk a lot about, but in general, that comes from the system model. And here we see the same process, which we were talking. You just connect to 3D experience, and then you drop the template-based the process into the Cameo, and then you execute, and then you get results. And all of that can come from requirements, stakeholder needs, what would be the needed parameters, and we run that analysis with the geometry in the loop and other models in the loop, and we get that those parameters will be satisfied, client requirements will be satisfied, and as a result, we can get system requirements, optimize system parameters for the next level analysis. So what are the next steps? So now we are working on the connector, which will be released end of the year for the proof of concept in aerospace and defense industry. And this not limited to this industry for sure, but this is the industry which is using system engineering very heavily. So that's why they are kind of leading this for many years already. And 2021 X Refresh 1 will have the general availability connector with the likely other type of specific capabilities when connecting, for the optimization trade studies, Monte Carlo analysis. We'll see what will be able to produce more or less, as integrated capabilities. As conclusion, Cameo combined with the simulation process and data management SPDM tools on the 3D Experience platform easily allows projects to make use of design exploration methods available on the platform as optimization, Monte Carlo simulation. This connectivity provides tremendous flexibility in incorporating complex analytical and design models with system mission and system of system models. Simplicity of connectivity easily enables digital integration from stakeholder needs to implementation. This is just like selecting the model and integrating with the analytical and design models through the process composer template. So this can't be easier. Mbse value is delivered with that fast change and what-if analysis, integrated change and what-if analysis, architectural alternative evaluation from the trade studies, from the architectural different architectures side, optimized efficiency. Then it's very important when we want to have the requirements for the solution, right? So we need to know what are the parameters so we can optimize and get those parameters. And will, in general, prevent costly late rework, what is the purpose of system engineering. So thank you very much for being today and for the going through this presentation, early part of this demonstration, I would say, because things will come soon and then will be more and more available material, and will be opportunity to get benefit of this, one of the best values which we can get, when we talk about digital engineering and Mbse, low hanging huge impact fruit.
Excellent. Well, thank you so much, Salis. That was an excellent presentation. And we'll now move into the Q&A session for today. We have a little bit of time for some questions. And it does look like we've had a few questions come in already. We'll get started. The first question, what industries do you feel are the most active in model-based systems engineering adoption?
So for sure, aerospace and defense is the leading one. But this is not limited in current days. Transportation and mobility is catching up very fast, and around the world in the system engineering, almost all OEMs. And medical devices is the third one, at least from our client perspective. Almost all companies which produce medical devices, they are also doing system engineering, and in current days, system engineering means model-based system engineering to be able to get this value as we see, from integrated models. Otherwise, it will be just again on paper. And for medical devices and healthcare is especially critical because they need to produce, evidence of the traceability and of the requirements, traced to the design and other things, safety. And all of that comes much easier with Mbse. You don't need to produce extra Excel to track two document connections.
Interesting.
Thank you for the question.
Great. So the next question, what is the current state of the art in the systems engineering integration with multidisciplinary analysis?
So as you can see here, we are kind of moving forward, which will be, soon available. But in industry, there is already for many years, vendors, tools which produce this as a ability to integrate and run your analysis. The unfortunate thing that most cases, it's very limited availability, because people see that, oh, okay, it requires some expensive tool, to do it, and also very much knowledge, in that tool and other things. Here in the source system, everything is integrated, so you get that out of the box, with a single installation. So that's the benefit. You will be able to get that very fast and very easy. But the industry already has many things, just on the high price and the limited availability, especially aerospace and defense. And that gives us actually better opportunity to come up as the easier available out of the box solution vendor, which will provide a solution for wider audience instead of very, very limited few people in each company.
Perfect. The next question. What do you see as the low-hanging fruit current Mbse and analysis state-of-the-art technologies provide?
It's a very good question. It's a hard question because, every time as kind of I work as a consultant, last 5 years, Mbse transformation in many companies, aerospace and defense, some medical devices, transportation and mobility, and always, you get ability to execute many things in that transformation, digital engineering, So it is a big topic in the company's migration from the paper-based or, disintegrated models. And always you try to find the low-hanging fruits, because you want that the buy-in from the management would be quick, and from the company would be quick, that they would see, okay, this works. Let's do next step, because, there are many other initiatives. We can take some bigger clients. We have 20 maybe initiatives, not only model-based system engineering, right? So if the model-based system engineering will not go forward so quickly, other will go quicker, right? So with Mbse, you can find those as a definition of the model of the system, right? So you can define actually the system in the single model, and then everyone who works on that, you can talk about that model, as a system, and then everyone is on the same page. You don't have, who knows what PowerPoint somewhere, right? That's like huge gain immediately, and that's a huge step, forward, because as you remember from the maturity steps, definition and the system model is the first step. Then the next step would be to do at least one analysis in the loop, right? So you can do maybe that analysis in the loop through FMU standards, maybe, something else. But through process composers we presented here, that would be the easiest way to do. If you have any other tool, any other analysis in the source system, you now could already connect that into system model and run in the loop. And then you can do, optimization, Monte Carlo analysis, trade studies, alternative evaluation, connect your design model parameterized with the SysML model. So that could be, the low-hanging fruit when you have the descriptive system model. In between that, you might think, that you need SysML executable model also, that you have that, system model described, but, execution of SysML model comes automatically. You just need to run it and you'll see, it executes or not. For sure, it's more, hard to create executable model, because then you'll see, okay, I'm using wrong port, or port works in different way than I'm using. But that's also good. It's also part of the learning process. And we have amazing trainings, for SysML and SysML simulation.
Interesting. Another question that has come in. So it looks like this is a great test for activities for verification of architecture alternatives against requirements. But how can we provide instant parameters to the workflow from the process connector?
Yeah, so once you execute, you provide the parameters, and activity can read those parameters and provide parameters to process connector through the connector to the process composer 3D experience. and then get results. But if you are talking about, how we can get those parameters from the process composer side, if you want to run, Cameo and system model from the process composer side, then you already have it. You already have the software execution connector, right? That you can execute Cameo in headless mode, and Cameo will execute simulation configuration, which you specify in SysML model, and that configuration can output the file, and then you can read that file as a result. So we have this, working, and I think every expert on Process Composer can run the Cameo software as in headless mode. We can just, this is public thing. You can run the command line. That command line will execute Cameo simulation, and the simulation should produce the file, because that's how we'll get the results to the Process Composer. And that file could include, for example, selected architecture parameters. Then you kind of run Cameo with some parameters, and you get one architecture parameters, and then you run Process Composer simulation based on that, run and then call Cameo with other parameters, and you get other type of the architecture parameters from simulation, and that would give you, ability to do the trade study on alternative architectures, in SysML.
Perfect. So it looks like that's all the questions that we've had come in. Salas, thank you so much for sharing your time and expertise today. I'm sure that the audience found this information very useful and informative.
Thank you, Michael, and thank you for this great webinar series. And specifically for this topic, much more information will come in future. This is a good time to present what's coming, so we use this opportunity because it's growing, everyone is now asking about this.
Excellent. Well, thanks so much for joining, everybody, and we'll see you at the next episode. Thanks so much.
Thank you. Talk to you soon.